In today's algebra video, we are going to graph piecewise functions. So those are functions that are not just made up of one equation, but rather multiple equations depending on the interval of the domain. Okay, so we're looking at a piecewise function here on the screen. F of x equals negative 1/2 x when x is less than 2, and f of x equals x when x is greater than or equal to 2. So the first thing I'm going to do is graph this top part right here. Okay, so part of our function is going to be f of x is negative 1/2 x. So that's a linear function. I'm going to rewrite it as negative 1/2 x plus 0 so it's easy to see what our m and b are. And if you recall from graphing lines, we're going to start at our b value, our y-intercept, and then we're going to use our slope, our rise over run, to build our line. So I've already graphed this line here in green for us. So my y-intercept was 0, so you can see that my line goes through the origin at 0, 0. And then I use my slope, negative 1/2, as my rise over run. So the rise is negative 1, which means I'm going down 1, and then to the right 2. So that's where I get this next point. Down 1, right 2, down 1, right 2. I can also go back to that y-intercept, and to continue to build my line in the other direction, I'm going to go up 1, left 2, up 1, left 2. And that'll give me the line spanning the entirety of the graph. All right, so now the line is graphed. However, this piecewise function says that I only use the function rule negative 1/2 x when x values are less than 2. So that means I don't want to see this whole line. I only want to see the part of the line that has x values that are less than 2. So if I draw, I'm going to go to my graph and I'm going to draw a vertical line that would be represented by the equation x equals 2, right? On that blue line that I just drew, all the x values are 2 on that line, right? So they want us to just draw this line, negative 1/2 x, when the x values are less than 2, meaning they're to the left of that blue line, because to the right of that blue line, all of my x values are more than 2, right? If I pick a point over here to the right of that blue line, that's the point 3, 1. The x value is bigger than 2. If I go over here, this is 4, 0. The x value is 4. It's bigger than 2. I only want to see x values less than 2. So what we're going to do is we're going to get rid of the part of our equation, the part of our line, that's after that blue line. We only want to see the parts of this equation, of this linear function, that occur when the x value is less than 2. So now, the last thing I need to decide is what's going to happen at the value of 2. Is that a point that should be shown? So because my inequality is x is less than 2, it's not less than or equal to, what that means is that at the value of 2, I'm going to put an open circle there to connect with my line. Okay, so an open circle showing that that is the limit of it, that is my stop, but it's not included in that line, all right, in this graph. So I'm done graphing the first part of this piecewise function, and now there's the other piece of it to graph. So the other piece is also going to be linear, right? So this bottom piece says y equals x, or f of x equals x. So I'm going to write this out in y equals mx plus b form as well. This is the same thing as y equals 1x plus 0. I didn't change the equation by doing that, right? 1 times x is still just x, and 0 plus anything is just that thing. All I did was make it a little more obvious for us to see what my b is and what my m is. Okay, so now I can graph this line, again starting at that y-intercept of 0. So that means I'm back at the origin. So I will do it in a different color this time. So I'm back at the origin, and now my slope is 1, or 1 over 1. So I'm going to do a rise over run of 1 over 1. So up 1, right 1 gets me here. Again, up 1, right 1, up 1, right 1. And I continue to build this line, right? And again, you can always go in the opposite direction because the line is infinite, and negative 1 over negative 1 is the same thing. So now I've extended my line in both directions. I am going to cut it though, but I'm first just showing it to you. So here is that second part of my function. This is y equals x. But they only want to see this part of the function when x values are bigger than or equal to 2. So similar to what we did with that last line, I'm going to cut this line as well. I don't want to see any of the values where x was less than 2. So I'm going to actually delete all of these, okay? I only want to see this line from a beginning value of 2. Now in this inequality, you notice that it does say x is less than or equal to. So when it has that or equal to, when it has the underline under the inequality, that means that the value of 2 is included. So the way that we're going to show that is we're going to make sure we make a really obvious closed circle on the value of 2, okay? So now this purple-ish, pinkish line is the line y equals x, but only seeing it from the values of x is 2 and higher. So all the values of x going to the right are higher than 2. So that dot on the green is open very obviously, and the dot on the purple should be closed very obviously. And that is my piecewise function graph for those equations. Okay, let's do one more. Graph the following function on the set of axes below. So I have f of x equals absolute value of x, but only between these values. So I'm going to graph that v that the absolute value makes, right, starting at the origin. So we're going to go build our points this way into a v, but then we're going to have to cut our function, right? So they only want us to show the function f of x equals x when x is between -3 and 1. Again, remember that including or not including is important. So the -3 is included because you see how that inequality symbol has the underline? So that means that x is greater than or equal to -3. So I'm going to go to -3 on my x-axis. Remember, we're always dealing with the domain, the x-axis. 1, 2, 3. So when x is -3, I'm at this point right here that I'm making a little more bold. We don't want to see anything that is less than that. We only want to see values that are bigger than -3. So I'm going to erase everything that's to the left of that. And that graph is going to start with that bolded purplish, pinkish dot there. Okay. Now, this inequality is a little more complex because it's not just saying I want to see everything bigger than -3. It's saying I want to see everything that's bigger than -3, but less than 1. So it wants us to be in between these two values. It only wants to see the part of this graph that's in between -3 and +1, including -3, but not including 1, because you see that the 1 inequality does not have the underline symbol under it. So as I start to erase and go only up to the value of 1, I'm going to make sure that I make it very clear that at 1, there is an open circle. Okay, so my graph looks like that for the first part of this. An open circle at the value of 1 that is connected. I know it doesn't look like it is. And a closed circle at the value where x is -3. So that's the first part of my function. So that one is done. Next one. Now it says f of x equals 4. So when y equals 4, that means we're dealing with a horizontal line, right? Where all of the y values are 4. So 1, 2, 3, 4. That's going to be a line that looks like this, right? A horizontal line at the value of 4 for y. Every point on that line has a y value of 4. This is 1, 4, 2, 4, 3, 4, 4, 4. So that's the line y equals 4. They only want to see that line, though, in between the values of 1 and 8. Now notice they both have the underline under the inequality symbol, meaning that the 1 and the 8 are both included. So we're going to do shaded circles on 1 and 8. And remember, these are always x values, always the domain. So let's go to 1 for the x value. I'm going to put a pretty obvious shaded dot there. And then we're going to go to 8. 2, 3, 4, 5, 6, 7, 8. And I'm going to put a very obviously shaded dot there as well. These instructions are telling us we only want to see the part of that horizontal line that's in between those two values. So I'm going to erase everything that's outside of those values. And that's the piece of the line that we're asked for. And I'll just make it a little more bold. Okay, so the purple-ish, pinkish graph and the blue graph together make up this piecewise function. Okay, this is one graph made of two different pieces, and the way that we graphed it depended on what our x values were. Okay, so anytime that x is a number between 1 and 8, including 1 and 8, we would use the bottom function where y equals 4, and anytime x is a number between -3 and 1, we would use the top function. And for values that are outside of that, this is not defined. Okay, I'm going to leave you with one more, but I'm not going to show you the answer. I'm going to have you maybe pause the video and try it on your own and see if you can graph this one. And then when you think you have it, you can hit play again, and I'll leave the answer up here. If your answer does not look like mine, please feel free to leave a comment, and I will try to help you figure out what your mistake was. All right, here's what that one should have looked like. So again, if yours doesn't look like mine, please feel free to leave a comment and ask for questions. If yours does look like mine, please give me a thumbs up and let me know that you got it right.